Hi, your next challenge in the Easy series is entitled Hacker Speak, and they even were kind enough to type it out in hipster letters for us up at the top here. So you are to create a function that takes a string as an argument and returns a coded hacker speak version of the string. And you've likely seen this before where people use numbers where letters should be. Sometimes you'll see the @ symbol for A or just really anything like that. Refer to the examples to make sure it's clear. JavaScript is cool, goes to this mess here that people think is cool, I guess. So, okay. Refer to the notes section so you understand the scope of which letters change and what they change to. They provide that information for us as they should. You replace all A's with 4, E's go to 3, I's go to 1, O's go to 0, and S's go to 5. So we've got, 5 letters there, mostly vowels. Instead of U, we're doing S. So I think we're good to start. Let's go over to the code section. As usual, this is your chance to pause and have a go at this. Resume the video when you're complete, or if you're stuck and want to see some ways to proceed. So I'll start. What I'm going to do first of all is to organize my replacement letters into a collection. There's only 5 of them, and I'm going to put them in a local array. I'm using, this is going to be a private member variable because the outside world doesn't need to know the details about how I go about solving this problem. So I want it to be private. It's like my scratch pad space where I work out my problems, and as long as I uphold my end of the public interface, everything's fine. And people don't need to know the details of how I'm providing that service. So I made mine private. We're going to make it a character array. And I'm going to call mine, let's call it letters to change. These would represent the letters of the alphabet that we need to replace with hacker code equivalents. So we're going to call that a new character array. And let me start this on a new line because it's going to get long. Now, if you remember, they had A, E, I, O, and S. Oops. We're using single quotes because these are characters. And then I'm also going to cover the capitalized versions of these here. There's probably a clever way of not doing this and using 2 lower or 2 upper methods to avoid this, but this isn't so bad in my opinion, so I'm going to do it right here. I had 5 characters, so 5 more isn't going to kill me. But anyways, this is my collection of characters that I'm going to be on the lookout for when I get a string in from the client. Now, I'm also going to have a public method to help me out that's going to take any given character and convert it to its hacker code equivalent. So let's call that public static. And remember, we're using static here because we're not dealing with instances of the program class. We're not dealing with program objects here. So the static word doesn't require you to have an object instantiated. Public static, we want the character equivalent. Let's call it get hacker char. When someone gives us a letter, a character representing a letter, we're going to return some character based on that. If it's in this collection, you'll see later, but in general, that's what we're going to do. So let's call, to shorten this method up, I'm going to just go like this. lowercase is going to be char to lower letter, and this will convert the input to a lowercase. So if it were a capital A, it would be converted to lowercase a. And when I do my subsequent switch statement, you'll see that's useful, that I don't have to write out a case line for every one of these. But you could do it that way too. Then I'm going to switch on this lower character that we have. We've done switch statements already. They're kind of like if-else statements. We'll do case A return 4, right? And note I'm using the single quotes again to make sure it's returning 4 as a character and not the integer 4. The integer 4 itself doesn't make sense here. So we're doing a character. And then I'm going to copy this, repeat it 4 more times for our other cases. There we go. By the way, I highlighted that and I held down Shift and hit Tab. The Shift tab pulls everything to the left. A tab goes to the right, in case you find that helpful. So let's get our other cases, which were E, I, O, and S. And remember, we're getting coverage for both the lower and the uppercase version here because we've knocked it down to a lowercase letter. So if you remember from the instructions, E should return 3, I should return 1, O should return 0, S should return 5. You're free to go back to the instructions tab and verify that. Now, what happens if the letter is not one of these characters that should be converted? Well, easy. Make a default case and simply return the letter itself. No processing needs to happen, just give it right back. And I think that does what we want it to do. So we'll convert characters as we encounter them. Okay, so now that I have some of this other infrastructure in place, that makes my job a little bit easier here. So what I'm going to do now is to declare a local string. Let's call it hacker text. And to start, we're just going to set it equal to the input. It's going to match. Then what I'm going to do is make a for each loop. It's called char letter in letters to change. I think that's what I called by private collection, letters to change. Yep. Letters to change. So we're basically going to iterate over each one of these characters. Then I'm going to say hacker text equals itself with the replace method. Remember, we used replace recently. You know what that does. And we're going to replace the letter encountered. In this case, one of the letters from our private collection here, whatever one we have. So let's say lowercase a to start. And then you want the hacker equivalent of that, right? So this is kind of like saying replace, let's start with lowercase a with the hacker equivalent character for the letter lowercase a. So, and you can see that returns 4. So it's going to say replace lowercase a with 4. On the second time, it's going to get lowercase e for that first parameter. And this method will return 3 when it hits lowercase e and put 3 in place of this whole statement. So you can imagine that turns into the character 3. This was lowercase e. And it goes through the text and looks for all occurrences of lowercase e and replaces them with 3. And then that process will continue for each one of these letters in letters to change. Each time the string is being reassigned to a new version. You don't modify strings directly, so we're making a new string with these replacements happening. After all of the letters to change have been processed, that's sort of the end of the sequence, right? We've gone over all of the letters that need to change. So we can simply say return hacker text. And I think that looks good. See, this job became pretty simple once we define this collection that it's already preloaded with all the letters that we're on watch for. Each time we started with the basic string, we're going to say, okay, take that string, replace all the lowercase a's. And we get some new string with just that character replaced. Then we go to the next iteration of the for each loop. It's going to have lowercase e. It's going to say, okay, take that string we just made, and now go through and process all the lowercase e's. Good, done. Comes into the next iteration of the loop. You get lowercase I. It's going to go through and replace all lowercase i's, etc., until it has exhausted all of the characters in this collection. After you've done that, all of the characters you needed to change have been applied, have been addressed, and you simply return that result. And let's see if we did it right. Name the char. Oh, sure. Can you see it? On line 15, the name char does not exist in the current context. If you want, pause and figure out how to fix that problem. Hopefully that's clear. We saw this in the last video that we need to bring in using system for that. That contains this char class because we didn't define this, right? This is some class outside of what we've typed here. So let's try that. And there you go. All green, check marks. So yeah, you can see that you can make life really simple for yourself. It's about breaking things down into really small pieces, doing all these helpers. Yeah, one thing to note with these private members is that a common technique is to precede them with an underscore character that denotes a private member variable. And these are handy when you're looking through methods and you see this. You can tell right away that something is a member variable as opposed to a local variable. And that gives you a clue that there are ramifications if you modify it outside of just any particular method that you're in where you encounter this. So that's a nice little technique to remember. Anyways, thanks for watching. If you have any questions, feel free to post them below.